Okay, let's talk about evaluating deductive arguments with truth tables. Okay, so to analyze arguments using truth tables, you follow these three steps. First, represent each of the premises symbolically. Two, create a conditional statement joining all the premises to form the antecedent and then using the conclusion as the consequent. Okay, so you're basically going to form one large implication or conditional statement with the argument. Okay, because what we're saying is we're saying if, right? So you've heard me say this before. Think about the argument, right? The deductive argument says if the premises are all true, then the conclusion must be true. So it is a conditional statement, right? So we're going to have a chain of and statements connecting the premises that's going to form the antecedent. And then we have the conclusion, which is going to form the consequent. And then we're going to see when is that true. Okay. So three, we're going to create the truth table for the statement. And if all the values, the truth values, is true, then we have the argument is valid. So in other words, if it doesn't matter what the truth values are, that the conclude that we get truths all the way down, we have a valid argument. This is known as a tautology. So if we can form a tautology using the argument, then it's valid. If there's if there's one instance where it could be false, then it is invalid. Okay, so let's do an example and show you how to do this. Okay, so in this example, we have the premises, the argument with the two premises. If you bought bread, then you went to the store. That's premise one. And then premise two is you bought bread. And then so the conclusion is you went to the store. So let's see how this pans out. So we're saying if premise one and premise two are true, then the conclusion must be true. Okay, so we're going to set that up as a conditional. Okay, so now while it's fairly obvious that it's a valid argument, we can analyze a truth table by representing each of the premises symbolically. Okay, and then we can form a conditional statement showing that the premises together imply the conclusion. And if the table is a tautology, then the argument is valid. Okay, so let's do that. So we're going to represent B. B represents the statement, you bought bread. S represents the statement, you went to the store. And then we're going to set up the argument symbolically this way. So premise one is B implies S. Premise two is B, right? You went to the store or you bought bread. And then the conclusion is S, you went to the store. Okay, so the way we're going to set up this is we're going to have the premise number one and premise number two connected with an and statement. Okay, so this is what we have. Okay, see how we're connecting the premises with a string of and with an and statement? And then we're putting it all in brackets because it's one large conditional. And so the main dominant symbol here is the second conditional, the large conditional for the argument. So that's the last thing we'll do. Okay, so the first thing we do is we set up our statements, right? Just like we do before, B and S. So we set up all possible truth values, combinations. Okay, so now we're going to do the B implies S. So we've got the B implies S here. Okay, and then the next thing is going to be the and part, right? So now we're going to set up the and part. And so we're going to look at the green columns and we set up the and part. So we set up the truth table, we fill in the truth values for the and part, right? And then the final step is now doing the large implication. So now we've got the truth values for this one, and now we look at the truth values of S. And remember, with implications, we're looking for a T followed by an S, right? So, or excuse me, an F, a T followed by an F. right? So we look at this and we say, okay, is there a T followed by an F? Is there a T followed by an F? And the answer is no. So guess what? All of these turn out to be true. And so since it forms a tautology, this is a valid argument. Okay? So let's do the same thing with the triad number 13 here. So it says, premise 1 says, if I have a shovel, I can dig a hole. Okay, so we'll say I have a shovel is S, and I can dig a hole is D. Okay, premise 1 or premise 2 says I dug a hole. So what is that? That's P. And the conclusion is, therefore, I had a shovel. So that's going to be S. Okay, so let's look at this one. Okay, so we have S and D. Okay, so we put up our combinations. So T, T, F, F, T, F, T, F. And now the first thing we're going to do is we're going to set up this argument symbolically. So we have, it's going to be what? S implies D, and then D, and then the conclusion S. Okay, and so the symbolic, so for therefore we put the triangle of dots. That's a symbol for therefore. Okay, so this is the way we would write our argument symbolically, right? So above the line are the premises, and below the line is the conclusion. Okay, sometimes we would put P1, P2. Oops, sorry, wrong. Not a bold P. P2 followed by and then C at the bottom, but we don't need that. Okay, so anyway, now the first thing we're going to do is we're going to do the implication. S implies D. So S implies D. I didn't give myself enough room, so I apologize. So again, we want S followed, or excuse me, T followed by F is false. So again, this is going to be T, F, T, T. Okay, now the next thing is we're going to do the and. We're going to connect the premises with an and. So we've got S implies D and D. Okay, so now we look at the two columns with those two. So we're looking for TT, right? If it's TT, it's true. Otherwise, it's false. Okay, so here we got two T's, so it's true. And then we get two F's, so it's false. Then we got two T's, which is true. And then we got an F and a T, so it's true. So it's only false if both are false. Okay, so now we're going to do the final implication, which is what? It's going to be S, oops. S implies D, and D implies S, right? So that's the final one. So now we're looking at this column and the first column. And again, we're looking for a T followed by an F. That'll give us false. As long as we get all T's, it's valid. If we get one F, we're done. It has to be invalid. So the first one, we get a T followed by a T, so that's true. The second one, we get a false, so it doesn't matter, it's true, because once the antecedent is false, that's the condition is always going to be true. And then we got, the third column gives us a T followed by an F. Guess what? That's an F. That's false. So therefore, we're done. Okay, now the last one is also false, but it doesn't matter. As soon as we get one false, we're done. This is going to be invalid. And we're done. All right, let's look at this example. Okay, so in this example, we have what? Premise 1 says, if I go to the mall, then I'll buy new jeans. Premise 2 says, if I buy new jeans, I'll buy a shirt to go with it. The conclusion then is, if I go to the mall, I'll buy a shirt. Okay, so this is actually another type of, well, we'll get to this later. Never mind. I'm not going to say that. I'm getting ahead of myself. So let's analyze this argument symbolically. So first of all, we're going to give each one of these a letter. So I go to the mall is M, right? I buy jeans, new jeans. That's going to be J. I buy a shirt is S, right? So now if I use those symbols, then each of the premises and conclusions can be written this way. Okay? So M implies J, J implies S, M implies S. Okay? So now what we have to do is we have to construct a truth table to test what? It's going to be this. Remember, we're going to take the premises and connect them with and. That's this part right here. And then we're going to make an implication that to the conclusion. We're going to form, this is the hypothesis or the antecedent. Okay? And this is the conclusion, right? And so we get one large implication. So this implication is the dominant symbol. That's what we want to show. Now, so again, with 3, we start with our 3 columns with all the possible truth values. And then we're going to do the 2 condition, the 2 premises, right? We got to do the truth table for the 2 premises, right? We do that. Then we're going to connect them with the and statement and find the truth value of the and statement. Then once we do that, then we're going to do the implication of M implies S. Now, technically, we could have put this over here, but it doesn't matter. We're trying to keep things where the columns are together in such a way it makes it easier for us to show the implication. So in this case here, we waited to do the M implies S so that it comes after this, so then it'd be easier. We can look at both these columns, okay? And then finally, we can get the truth value of the final implication by looking at at these 2 columns here and just looking for a T followed by an F. So here we've got T followed by a T, so we're good. All the ones that have F's here, we can ignore because they're automatically true. The only thing we have to look for is a T followed by an F. A T followed by an F. And so guess what? There are none. So guess what? All of these are true. We have a tautology, which means this is a valid argument. And we're done. Okay, so we'll stop there and we'll come back and we'll talk about forms of valid arguments. This is where we're going to talk about the structure of the argument. And if it has the right structure, it's valid. And if it doesn't have the right structure, or if it has a particular different structure, it's automatically invalid. So, and then we don't need truth tables. We'll know that it's valid or invalid by the form or structure of the argument.